Hello, you're welcome to Mathematical Methods and Introductory Curriculum. This is our first topic and it's called Algebra. Algebra basically means the four fundamental operations in mathematics, and that is addition, subtraction, division, and multiplication. So how you play about all of that is what we call algebra. So this is basically the basis of mathematics, and we've all studied algebra since nursery, since abacus. So we are basically going to look at addition, subtraction, division, and multiplication of expressions. So starting with addition and subtraction, if we have terms, for example, 4x, 3x, negative 2x, and x, the summation, if the unknowns are the same, for example, in this first expression, the unknown is only x. So if the unknowns are the same, you basically just add or subtraction. And please note that subtraction and addition are commutative, so meaning that you can either start with addition or subtraction and the result will be the same. So if we have, in the second example, we are having a 5x, 3y, z, negative 3x, and 4y. So here we note that our unknowns are different. So taking an example of if x are oranges and maybe y are mangoes, we can never add or subtract mangoes and oranges. So once we have expressions, an expression with unlike terms, the first step is to always collect like terms. So we only add or subtract similar terms or terms that have the same unknown. So in this case we have a 5x and a negative 3x, so we shall consider that. And then we also have a positive 3y and a negative 4y, which is this. And then we also have, so we only add and subtract like terms. So first step is to always collect like terms together, and then after you can add or subtract those like terms. So once we get the simplest form of each term, we leave it at that. We can't add to get one figure. So the other scenario is if we have a power on one of the unknowns. So this is 4x squared minus 4x minus 2y plus 5x plus 3y. So however much we have a 4x squared and maybe a negative x, these two terms are not similar. So an x with a power cannot be added or subtracted from an x with a power 1 or just a mere x. So we shall maintain our 4x squared because it doesn't have any other like term. Then we can treat negative x and 5x as like terms, and then negative 2y and positive 3y as like terms. So our result will be positive 4x squared plus 4x plus y. Then the other scenario is if we have a product of unknowns, still for you to be able to add or subtract terms in an expression, the unknowns should be exactly the same. So here we have a 3xy and then a negative 7x or even a positive 2x. So this term is very different from 3xy. So still we look for what looks exactly like this. So therefore we shall only be able to add 3xy plus 4xy, and then that negative 7x and positive 2x will also be treated as like terms. So please note, so that is basically what we need to take as a serious point when we are adding and subtracting expressions. So we only add or subtract like terms. So with that, we can also look at multiplication. So multiplication is simpler in a way that each term is considered as an independent term. For example, if I have BC times ABC, so you multiply a B times a B, then a C times a C, then the A is also multiplied by a 1 this side, because A is not there, meaning it is represented by 1. So each term is treated independently. Then our next example is simplifying negative 2p times negative 3p. Remember from our primary mathematics times that a negative times a negative will always give us a positive, or an enemy of your enemy will always be your friend. But then an enemy of your friend will be your enemy. So a negative times a positive, we get a positive, and a positive times a positive, we always get a positive. A friend of your friend will always be your friend as well. So please take note of that. So if we have a negative 2p times negative 3p, we multiply the first two terms, or the first two constants. So negative 2 times negative 3 gives us a positive 6. Then also p times p will give us p squared. So with that, we can have another example, 3ab plus, evaluate 3ab plus 4bc minus ABC. So when A is 3, B is 2, and C is 5. So here what we do, we just substitute. Our A is a 3, then we substitute a B with a 2 and a C with 5. Then after we've substituted, then we can, we are going to look at BODMAS, or the law of precedence. But here right now what we do is a matter of substituting, and once we substituted, we multiply and simplify to get the answer. Then we can also evaluate 5p squared. So this was supposed to be q squared times r cubed. Still there, we just substitute and then multiply. So if we want to multiply 2a times plus b, 3b by a plus b. So what we do, we can first create brackets to each term, and then we multiply each term in the one bracket by the entire bracket. So if we start with a times 2a will give us 2a squared. Then b times 3b will give us 3ab. Then b times 2a will give us 2ab, and then b times 3b will give us 3b squared. So when we add that 2, we get 2a squared plus 5ab plus 3b squared. Please, I want you to try out each and every example to see that you follow the step and get the same answer. And then when we meet, we shall just be going through what has not been clear to you. So that is multiplication. And now division. We all remember our long division. So that what is down, or what we are dividing by, is called the dividend, and then what divides is called the divisor. So if we have an example of multiplying 2x squared plus x minus 3 by x minus 1. So x minus 1 will be this side of the division sign. And then here what we do, we only consider the first terms of the two expressions. So what we are dividing by, which is 2x squared, sorry, this is supposed to be 2x squared. So 2x squared, we only look at the first term. So in this term, we are going to look at 2x squared, and then here we shall look at x. So we are going to divide 2x squared by x. So 2x squared divided by x, we get 2x. And then from our long division of primary, you know that once we get this, we multiply it by what we've divided it with. So 2x squared, 2x divide times x, we get 2x squared. Then but we are multiplying this by the entire expression. So 2x times -1, we get -2x. So when we subtract that 2, we shall have 3 minus 0, which is a negative 3 minus 0, which is a -3. Then x minus -2x gives us 3x. Then 2x squared minus 2x squared will give us a 0. So when we simplify, we are left with 3x minus 3. So remember I said that we only consider the first term and the first term. So 3x divided by x, we get a positive 3. So positive 3 times x, we get 3x, and then positive 3 times -1, we get a -3. So when we subtract that 2, we get that 0. So therefore, the result will be 2x plus 3. So that gives us the solution to this. So when we divide 2x squared plus x minus 3 by x minus 1, our result will be 2x plus 3. So we can prove this by multiplying the 2x plus 3 by x minus 1. So that is it with division of expressions. So after that, we shall look at the laws of incidence. And an index is a number that is raised to a power. So for example, if I have 16, I can write 16 in terms of 2. So if I want to express 16 in terms of 2, that means finding how many times 2 repeats itself to get 16. So 2, if you multiply 2 4 times, the product will be 16. So 2 to power 4 is the same as 16. So meaning I can as well write 16 as 2 to power 4. They all mean the same. So here 2 is the base and 4 is the power, all the index. So this expression is known as 2 to power 4. So having known that, we need to also understand the laws that govern such numbers, or that govern indices or numbers that are raised to powers. So the first law states that when you're multiplying numbers of the same base, we maintain the base and add the powers, all the indices. So if, for example, I'm multiplying 2 to power 2 times 2 to power 3, we see that the bases are the same. The base is 2. So what I do is just to maintain my base, which is 2, and then add the powers. So if I maintain 2, I then add 2 plus 3, which are my powers, and 2 plus 3 gives us 5. So this gives us, so 2 to power 3 times 2 to power 2 gives us 2 to power 5. So to prove that, we can expand manually. So 2 to power 2 means 2 is multiplying itself 2 times, and then 2 to power 3 means 2 is multiplying itself 3 times. So if I multiply 2 times 2, I will get 4 times 2. I will get 8, then times 2, 16, and 16 times 2 will give us 32. So likewise, if you expand 2 to power 5, we shall get 32. So that is rule number 1, or law number 1. When you're multiplying numbers of the same base or indices of the same base, we maintain the base and add the powers. Then the second law states that when you're dividing numbers of the same base or indices of the same base, we subtract the index of the denominator from the index of the numerator. So for example, if we have 2 to power 5 and we are dividing it by 2 to power 3, we maintain our 2 and then subtract 3 from 5. So 2 to power So that will be 2 to power 5 minus 3, which gives us 2 to power 2, giving us 4. So we can also prove by first expanding manually to see whether we get the same answer. Then the third law states that when a number is raised to another power, or when an index is raised to another power, we maintain the base and then multiply the indices. So for example, if we have 3 to power 5, but again it is raised to power 2, we maintain our 3 and then multiply 5 by 2, giving us 3 to power 10. The other scenario or rule number 4 is when you have a number raised to power 0, its value is always 1. So whether we have 1,000 to power 0 or 1 to power 0 or 500 to power 0 or 10,000 to power 0, its value will always be 1. That is our law number 4. Then law number 5 states that when a number is raised to a negative power, the reciprocal of that number is the same as having that number raised to a positive power. So from our P4 mathematics, we know that a reciprocal is got by interchanging a fraction. So for example, if I have 3, its reciprocal will be 1 out of 3. Or if I have 1 out of 3, its reciprocal will be 3. So if I have 3 to power negative 4 and I want to rewrite the power as a positive, I will get the reciprocal of this index. So that will be the same as having 1 over 3 to power positive 4. So likewise, if I had 1 out of 3 to power negative 4 and I wanted to write it as a positive, that would be the same as having 3 to power positive 4. So you get the reciprocal of the number and then change the sign of the power. So that is law number 5. Law number 6 is that when a number is raised to a fractional power, the denominator of the fraction is always the root of the number and the numerator is the power. So the denominator is the root and the numerator is the power. So an example is if we have 8 to power 2 out of 3. The denominator of the power is 3, so meaning we are getting the cube root of 8, but 8 is raised to power 2. So what is the cube root of 8? That is 2, and then 2 to power 2 is 4. So the denominator is the root and the numerator is the power. So those are the 6 laws that govern indices or numbers that are raised to powers. There is an example here that I want us to try out and then follow each and every step in your books to see that you get the same answer. So we are simplifying d squared times e squared times f to power half over d to power 3 over 2 times e times f to power 5 over 2, and the whole thing is squared. So this example encompasses all the different laws. So the first step is to always collect like terms, and then we first work out brackets. So this was the same as if we first open our bracket on the denominator, because we see the denominator has a power. So that means the square, each term in the denominator is going to be multiplied by 2, or the power is going to be multiplied by 2, or each term is going to be squared. So that's why we are having d to power 3 over 2 times a 2, and then e to power 2 and f to power 5 times 2 over 2. So that gives us, the numerator did not change, so that gives us, we are going to cancel this 2 and this 2, so d to power 3 times e squared times, also this 2 is going to cancel, so times f to power 5. So from that we collect like terms. So in the process of collecting like terms, we see that d squared and d cubed are being divided. So we are going to maintain the base and subtract the power of the denominator from the numerator. So that's why we have d to power 2 minus 3. Then e is also dividing, so we are maintaining the base and subtracting the powers. So it is e to power 2 minus 2. And also f is dividing, so we shall have f to power a half minus 5. So 2 minus 3, we get negative 1. So sorry, this d had to be down. And then e to power 2 minus 2 gives us a 0. But then remember rule number 4, any number raised to power 0 is 1. So that means e to power 0 can also be expressed as 1. And then we can also subtract 5 from a half. So you try out and see the answer you get. So I think since we have a negative here, that d has to be raised to power negative 1. So it is not d but d to power negative 1. Please take note of that. So with that, we can also look at factorization. And factorization is basically the opposite of expansion. So for example, if we have 2 and we are multiplying it by a bracket a plus b, when we expand it, that is expansion. But then if we had 2a plus 2b and we want to simplify it or write it in its simplest form, we look for common terms or a common term and we pull it out. So that process of pulling out a common term in an expression or common terms in an expression is what we call factorization. So this is basically expansion where we multiply each term by the bracket. So we looked this when we were looking at multiplication in our first sub theme, which was algebra. So the process of removing brackets is what we call expansion. And remember that, please note that when we are removing brackets, we always first deal with the innermost bracket. We always first deal with the innermost bracket. So here we have 3 types of brackets. I think we have this bracket, we have the one that looks like a set, and then we have the square or rectangular brackets. So we start with the innermost. So I think the innermost are at 5a, sorry, a plus b times 5 and also a minus b times 5. So we shall always start by expanding that. So that's 2 times 4a, which is 8a. Then 2 times negative b giving us negative 2b. Then 5 times negative 5 times a giving us negative 5, and then negative 5 times 2b giving us negative 10b. So once we've expanded that, then we also open the next bracket. So you start by, but we can see that we have some like terms. So the other thing, next step would be to collect like terms and then deal with the brackets. So once you do all that, then we shall have expanded our brackets. So the opposite of that is factorization, and I said that factorization is looking out for a common term, and here we always consider factors. So an example, if we want to get the factors of 8, we look for numbers that can be divided by 8. So 8 divides by 1, 2 is also a factor of 8. We can divide 8 by 5 and not get a remainder. And also 8 can be divided by 4 without getting a remainder. So 8 divided by 4 gives us a 2. So therefore 1, 2, 4 and 8 also 8 divides itself to get a 1. So 1, 2, 4, and 8 are all factors of 8. Meaning where we get an 8, we can actually express 8 in terms of 1, 8 in terms of 2, 8 in terms of 4, 8, 8. So if we want to compare the factors of 8 and let's say 24, what are the factors of 24? Which numbers can be divided by 24? So we see 2, 3, 1, 2, 3, 4, 6, 8, and 8, 12, and 24 can be divided by 24, or they are factors of 24. So of the factors of 8 and factors of 24 which are common, we see that 1 is common to all, 2 is common to all, 4 is common to all, and 8 is common to all. But of all these, which one is the highest common factor? And I think the highest common factor that is to both is 8. So therefore I can express 8 and 24 in terms of 8. So when two or more terms in an algebraic expression contain a common factor, the factor can be shown outside the bracket. So for example, if we have df and dg, we see that d is common in both terms, so we can pull it outside, and inside we shall be left with f plus g. So this is the process that we referred to as factorization. So here are some examples. If we want to factorize 2x squared plus 14x y cubed, we look for common terms. Which terms are common in both expressions, or in both terms of the expressions? Or what can we express in terms of the other? Can we express 2 in terms of 14, or can we express 14 in terms of 2? I think we can. So we can write 14 in terms of 2, so that is dividing 14 by 2 and seeing what we get, which is a 7. But we also have an x here and an x here, so we can divide this x and this x to get x. So for the terms, we have x squared and x. So the highest common factor of x and squared and x is x. But we also have a 2 and a 14. And we can also, so we can take out the 2 and the x from each term and to go outside the bracket. So what multiplies 2x to make 2x squared? So we multiply it by x. And also what multiplies 2x to make 14x squared? To make 14x y cubed, we multiply it by 7. Remember, we are multiplying by 2, we multiply it by 7y cubed. So therefore, if we pull out our 2x, we shall be left with x plus 7y cubed. So the other example is 2ax, negative 3ay plus 2bx minus 3by. So so when you have an expression of more than 2 or more than 3 terms, we can break the terms into 2 by looking at like terms. So if we consider the first bit of 2ax minus 3ay, what is common in both? We have an a. So we can pull out the a in the first 2 terms. So we shall have a into 2x minus 3y. Then b is also common in the next set or bit of the expression. So we can pull out b and we shall be left with 2x minus 3y. So giving us a plus b into 2x minus 3y. So similarly, we could also consider x and y. So in the first expression, if we collect like terms 2x, 2ax and 2bx and also 3ay and negative 3by. So if we pull out 2x in the first set of the terms that have x, if we first pull out 2x, we shall be left with a plus b, and then